Multiple linear regression. What is multiple linear regression? Multiple linear regression is used to estimate the relationship between two or more independent variables and one dependent variable. You can use multiple linear regression when you want to know 1. How strong the relationship is between two or more independent variables and one dependent variable. Example: how rainfall, temperature, and amount of fertilizer added affect crop growth. 2. The value of the dependent variable at a certain value of the independent variables. Example: the expected yield of a crop at certain levels of rainfall, temperature, and fertilizer addition. Multiple regression is an extension of linear (OLS) regression that uses just one explanatory variable. MLR is used extensively in econometrics and financial inference. Formula and calculation of multiple linear regression. Y equals beta 0 plus beta 1 x1 plus beta 2 x2 plus beta n xn plus e, where n equals number of observations, y equals dependent variable, x equals explanatory variables, beta 0 equals y-intercept, constant term, beta n equals slope coefficients for each explanatory variable, e equals the model's error term, also known as the residuals. Assumptions of multiple linear regression. Below are some important assumptions of multiple linear regression. 1. Linear relationship. 2. No autocorrelation or independence. 3. No multicollinearity. 4. Homoscedasticity. 5. Normal distribution of error terms. Why multiple linear regression? To predict the outcome from multiple input variables. Duh! But, is that it? Well, hold that thought. Consider this: suppose you have to estimate the price of a certain house you want to buy. You know the floor area, the age of the house, its distance from your workplace, the crime rate of the place, etc. Now, some of these factors will affect the price of the house positively. For example, more the area, the more the price. On the other hand, factors like distance from the workplace and the crime rate can influence your estimate of the house negatively, unless you are a rich criminal with interest in machine learning looking for a hideout. Yeah, I don't think so. Disadvantages of simple linear regression. Running separate simple linear regressions will lead to different outcomes when we are interested in just one. Besides that, there may be an input variable that is itself correlated with or dependent on some other predictor. This can cause wrong predictions and unsatisfactory results. This is where multiple linear regression comes into the picture. Measure of output. The coefficient of determination, R², is a statistical metric that is used to measure how much of the variation in outcome can be explained by the variation in the independent variables. R2 always increases as more predictors are added to the MLR model, even though the predictors may not be related to the outcome variable. R2 by itself can't thus be used to identify which predictors should be included in a model and which should be excluded. R2 can only be between 0 and 1, where 0 indicates that the outcome cannot be predicted by any of the independent variables, and 1 indicates that the outcome can be predicted without error from the independent variables.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.